When talking about data structures, now there are two things before creating a project or creating any program which is going to execute and which is going to solve a certain problem that you have. So data structures is one thing that you need to know, that how do you organize your data. This is going to answer how you organize your data. So how to organize data so that the operations on the data are most efficient. So efficient operations चाहिए आपको. This is one aspect. After getting the efficient operations and organizing the data in the proper manner, you write a program. Now, how to compare one program is better or second program is better? So one method to compare is to see which one is taking how much time to execute. The lesser the time, the better it is. Or how much space everyone is going to take. Again, lesser the space, the better it is. Or nowadays, so we have networking, web designing. So how much data consumption or data network consumption is going to happen. So the lesser the consumption, the better the program is. And so on and so forth. There are other methods. So we have something called as time complexity and space complexity of an algorithm. So when I'm talking about any program or algorithm, it is just a sequence of steps that we are going to follow so that the desired output can be achieved from the given input. That is simply an algorithm. Now, let us take a very small example here. I am writing a program, say void main, and within the main I'm calling a function, say test 5. I'll just tell you what I'm doing, and I close the main function, and I've created void test. Now I'm having, say, integer n here, and here I'm taking supposedly printf. Now the one difference where we will be coming in C and C++ is I am using a printf here, and I prefer using integer main, although I can use a void main in C also, but I am using an integer main, so I will be having a return 0 here, and I am using hash include. Now earlier we were having iostream.h. There is no iostream.h that we will be having in C. We will be using stdio. This is standard input output.h. So we will be using standard input output.h as the header file. This header file has the function printf. जैसे हम सी आउट कर रहे थे सी में, सी प्लस प्लस में. Now the cout is replaced by the printf function here. So cout was the object of the class that we were using. Now we are going to use the printf function. Printf function का syntax क्या है पहले ये समझ लो. So printf function has two kinds of parameters. First parameter you give within the parenthesis, within the double quotes, whatever you want to write. Supposedly you want to write hello and you want to print the value of n. Now there are something called as storage specifiers. Storage specifiers. So more detail about this I will give you in the practical class, but for the time being, in percentage D represents decimal, percentage F represents float, percentage C represents character, and so on. So printf function में जो भी print करना है that we give within these double quotes, and this gets printed on the screen. So if you want to print a variable, so here I am doing hello, n is equal to, and I am writing percentage D. Percentage D का मतलब it will be replaced by the value of a variable. That value of the variable you mention here, end the double quotes, give a comma, and mention the variable n. Fine. And supposedly you end the program. You can give a backslash and anything. New line would not work here. You will, अगर आपको new line चाहिए, so endl would not work here. You will have to give a backslash n. And normal, everything else you can do here. जैसे आप cout में करते हो. Only if you want to mention a variable or multiple variables, you can cascade. You will be mentioning percentage D for integer type. कैरेक्टर के लिए परसेंटेज सी, परसेंटेज फ्लोट एंड सो ऑन. We'll cover more of these in the practical part. Don't worry, practical में we'll do it. So let's see. Supposedly this is a program. Now I want to find out t of n. This is a function which tells me time taken by a program of size input n. Input n inputs जा रहे हैं उस program में. So for n inputs, how much time is the program going to take? So we want to create a function. So when I am creating a function over here, if you can see, when I am trying to finding out here, so अभी तक कोई executable statement नहीं है. From here the execution will begin. This is one statement. So this is going to call 1. Then I come here. This is another statement. This is going to take 1 unit of time. Supposedly every statement takes only 1 unit of time. Go back here, another statement takes another unit time. So technically 3 executable statements are existing. So your program Tn is equal to 1 plus 1 plus 1, which is equal to 3. As you can see, this 3 is independent of n. n से कोई मतलब नहीं है, कोई भी input हो, 3 ही statements execute होंगी. This much time will be taken. So 3 units time would be taken. Right? This is how we can calculate the time complexity for any program. कितना time लग रहा है. Now supposedly 3 statements simple नहीं है. Now I change the statement. I change the program and I take for, so I'm taking an integer I. I'm taking for I is equal to 0, I less than n, I plus plus. It's a for loop, normal for loop. And here I am doing printf. And supposedly I am printing I. So I am printing I. So 1, 2, 3, 4, 5 till 5 would be printed. Sorry, 0, 1, 2, 3, 4 would be printed since I am beginning with 0. And I close this. Now, when I am going to recalculate the execution time here, so this instruction is going to take 1 time. This loop, when I analyze the loop, this initialization will take 1 time. This I less than n कितनी बार चेक होगा? पहले जब आप लूप में एंटर करेंगे तब, जब आप लूप से एग्जिट करेंगे तब. So this condition is checked for n plus 1 times. जैसे just for example, I is equal to 0, I less than n. तो 0 less than 5 is true. 0 के लिए चेक होगा 1, 2, 3, 4, 5 तक चेक होगा. So 5 plus 1, 6 times the condition is checked. And this I plus plus, this will also happen n times. जितनी बार condition true है उतनी बार ही happen होगा. This statement is going to take 1 time only. So if I total all the times over here, how much time is going to be taken? It is not 3 anymore. It becomes 1 plus 1 plus 1 plus 1 plus n plus 1 plus n. So plus 1 plus n plus 1 plus n. And this printf instruction is actually executing n times. जितनी बार ये term true है, उतनी बार this instruction is executing. So this is executing n times plus n. So if I totally calculate, this is 3n plus 5. As you can see, अब जो हमारा function बना है वो n की terms में है कुछ. फिर से चेक करते हैं आपका क्या मतलब है. चलो फिर से लेट अस ट्राई टू सी व्हाट वी आर ट्राइंग टू से. कुछ भी समझ में नहीं आया तो मैं ये देखना चाह रही हूँ कि हाउ मेनी इंस्ट्रक्शंस आर गेटिंग एग्जीक्यूटेड. आई से एवरी इंस्ट्रक्शन takes 1 unit time for execution. I am explaining again. Every instruction takes 1 unit time for execution. जब हमें 1 यूनिट टाइम लग रहा है हर इंस्ट्रक्शन के लिए, मुझे निकालना है इस प्रोग्राम को एग्जीक्यूट करने के लिए टोटल कितना टाइम लगेगा. टोटल कितना टाइम लगेगा मतलब टोटल कितनी इंस्ट्रक्शंस एग्जीक्यूट होंगी. जितनी इंस्ट्रक्शंस एग्जीक्यूट होंगी उतना ही टाइम लगेगा ना. ये समझ में आ गया सबको यहाँ तक? The number of instructions executed will be the number of total time, assuming every instruction is taking only 1 unit time. ये क्लियर हो रहा है, ठीक है? Now understand when I am trying to find out the total Tn, एक फंक्शन क्रिएट कर रहे हैं, n is the size of the input, उसके अकॉर्डिंग आई एम ट्राइंग टू कैलकुलेट द टाइम फंक्शन t of n. अब हम क्या कर रहे हैं, ये एग्जीक्यूटेबल इंस्ट्रक्शंस नहीं है, ये सिर्फ कंपाइल टाइम पे ही कुछ कुछ होगी. जब एग्जीक्यूशन होगी तब ये इंस्ट्रक्शन रन करेगी और ये इंस्ट्रक्शन रन करेगी, ये ठीक है? एक सिंगल इंस्ट्रक्शन फंक्शन कॉल करने की कोई टाइम लगेगा, दूसरी इंस्ट्रक्शन को दूसरा यूनिट टाइम लगेगा. अब जब हम यहाँ पे आए तो अगेन दिस इंस्ट्रक्शन विल टेक 1 यूनिट टाइम. नाउ फॉर लूप में ये 3 इंस्ट्रक्शंस हैं. i इज इक्वल टू 0 सिर्फ एक ही बार होगा, जब आप लूप में एंटर करेंगे सिर्फ एक ही बार दिस विल रन. यस और नो? एंड अब हम रन करके देखते हैं इस लूप को एक बार. लेट अस ट्राई टू रन दिस. तो we'll get to know how many instructions we are executing. So when I am calling n5 के लिए ये कॉल हुआ, i 0 हो गया, i is equal to 0, n is equal to 5, ठीक है? Now first time i को 0 करा, 1 टाइम ये इंस्ट्रक्शन एग्जीक्यूट हुई. i less than n, भी चेक 0 less than 5, 1 बार ये इंस्ट्रक्शन रन हुई. i प्लस प्लस अभी नहीं हुआ, गए आपने प्रिंट करा, सो यू प्रिंट 0. You go back, you again check the instruction, so you increment the value of i, so i becomes 1. अब एक बार ये इंस्ट्रक्शन एग्जीक्यूट हो चुकी है और एक बार ये हो चुकी, ठीक है? Now you again check the condition 1 less than 5, so now the condition has been checked twice, again true, re-execute the instruction. Second time ये वाली इंस्ट्रक्शन एग्जीक्यूट हो रही है, so you print 1, a new line, and you print value of i 1. Again go increment, so this instruction gets executed twice, i becomes 2, again check 2 less than 5, that means ये condition जो है वो third time check हो रही है. Again true, re-enter the loop, print the value here, and this instruction gets executed for the third time. Again increment happens for the third time, i becomes 3. Recheck the condition 3 less than 5. 3 less than 5 is still true, fourth time. The condition is checked. Again print the value of i. 3 gets printed. This instruction has executed the fourth time now. Again increment. Fourth time increment hui. I becomes 4. Recheck the condition 4 less than 5. 4 less than 5 is true. Fifth time I am checking this condition. True. Reprint the value of I. This instruction has run for the fifth time. Re go here, फिर से check करा, i plus plus हुआ, i becomes 5. This instruction is executed fifth time. फिर से check करा आपने, 5 less than 5. Now this becomes false. But this instruction condition check हुई है sixth time. अब आप loop में enter नहीं करोगे, ये instruction execute नहीं होगी, आप बाहर आ जाओगे, यहाँ से वापस चले जाओगे. So the condition जो है वो loop में enter होते हुए भी check होगी, लूप से एग्जिट होते हुए भी चेक होगी. सो द कंडीशन इज, हाउ मेनी टाइम्स द कंडीशन इज चेक, इट इज चेक्ड n plus 1 टाइम्स. हाउ मेनी टाइम इंक्रीमेंट टेक्स प्लेस? फर्स्ट टाइम इंक्रीमेंट नहीं होगा, लास्ट टाइम इंक्रीमेंट होगा. सो 5 टाइम्स द n टाइम्स द इंक्रीमेंट इज हैपनिंग. जितनी बार लूप चला उतनी बार लूप के अंदर की इंस्ट्रक्शंस एग्जीक्यूट हुई. सो 5 टाइम्स और n टाइम्स दिस इंस्ट्रक्शन इज एग्जीक्यूटेड. नाउ इज इट क्लियर टू ऑल ऑफ यू?
मैम.
हाँ बेटा.
मैम एक डाउट है.
हाँ बच्चे.
मैम अगर हम i को जब डिक्लेयर कर रहे हैं तभी उसे इनिशियलाइज कर दे 0 के इक्वल.
बेटा फॉर लूप है
और
तो
फॉर लूप में
इनिशियलाइजेशन
अगर हम,
इंस्ट्रक्शन तो एग्जीक्यूट होगी ना, हम फॉर लूप की बात कर रहे हैं.
मैम बट अगर हम फॉर लूप बिना स्टार्ट कंडीशन के लिखे तो?
हाँ तो नहीं होगी. मतलब इफ यू omit the condition only itself, तो वो यहाँ पे नहीं एग्जीक्यूट होगी. यू आर करेक्ट, दैट कैन बी डन.
मैम तो वो एक कम हो जाएगा, मतलब 3n plus 4 टाइम्स चलेगा, उसका टाइम कॉम्प्लेक्सिटी
बट वी
है.
आर नॉट इंटरेस्टेड इन 1. यू जस्ट सी, दैट इज नॉट व्हाट वी आर इंटरेस्टेड इन. एक से फर्क ही नहीं पड़ेगा, हमें जहां फर्क पड़ेगा n से फर्क पड़ेगा. वी विल सी दैट, वी कैन डू दैट मुस्कान.
ओके मैम.
i की तरह
ओके
n को
मैम, थैंक
डिक्लेयर
यू.
नहीं कर सकते का क्या मतलब हुआ? n को डिक्लेयर करा तो है हमने, तभी तो डिक्लेरेशन मींस आई एम गिविंग n अ टाइप, डेटा टाइप. n हैज बीन डिक्लेयर्ड टू बी ऑफ टाइप इंटीजर, तभी तो उसे यूज कर रहे हैं. इंटीजर n करा तो है बेटा, तभी तो वो पैरामीटर है. n is declared to be an integer, तभी तो हम उसे यूज करेंगे. इट इज द फंक्शन पैरामीटर ना, फंक्शन का आर्ग्यूमेंट है ना. ठीक है ना सुषमा? सो नाउ इफ आई कैलकुलेट द टाइम, हाँ परसेंटेज डी में आप n लिखो, यहाँ पे कुछ भी कर सकते हैं, अप टू यू. n लिख सकते हैं, पिछले क्वेश्चन में n ही तो प्रिंट करा था हमने. n की वैल्यू चेंज नहीं हो रही ना, i की वैल्यू चेंज हो रही है, इसलिए मैंने i ले लिया इस बार. So now if I recalculate the total time taken, so the total time taken here would be 1 plus 1 plus 1 plus 1 plus 6, which is n plus 1 plus n plus n. अब ये ठीक है? 1 plus 1 plus 1 plus 1. This is n plus 1. This is n and this is n. अब क्लियर है सबको ये? Yes or no?
मैम
है बच्चे? क्या बोल रहे हो निशी?
मैम ये इंट मेन वाला भी एक काउंट हुआ है ना?
Int n will also take one time. Oh yes, you can say this. This is actually test 5 जब कॉल हुआ तो उसमें कॉपी हुआ. चलो, I will say this is also taking 1 unit time. ठीक है?
नहीं मैम, मेरे को वो समझ नहीं आया. जैसे आपने ऊपर 3 बार +1 लिखा है ना,
फिर से पूछो.
तो आप पहले एक वो वाला वन इरेज कर दो. एक
इस 1 से कोई फर्क नहीं पड़ने
मैम
वाला. 1 को भूल जाओ आप सब. ठीक है?
नहीं मैम, उसको छोड़ के जो बाकी के फर्स्ट लाइन में 3 + 1 है, तो एक 1 है टेस्ट 5 का, एक है रिटर्न 0 का, और तीसरा किसका है फिर?
इंटीजर आई.
पर मैम इंट आई का तो सेकंड लाइन में 1 लिखा हुआ है.
I is equal to 0 है ये 1. I will again rewrite what I am saying. 1 plus 1 plus 1 plus 1 plus n plus 1 plus n plus n. 1 plus 1 plus 1 plus 1 plus n plus 1 plus n, ये हुआ लूप और ये प्लस n हुआ प्रिंट एफ. अब ठीक है? 1.
Yes ma'am, got it.
So if I am going to add all of these, it becomes 3n plus 5. So this becomes my function. This is my time complexity function. कितना टाइम लग रहा है इस प्रोग्राम को एग्जीक्यूट करने में इन टर्म्स ऑफ n. जैसे जैसे n का साइज इंक्रीज होगा उतना इसको ज्यादा टाइम लगेगा, उतनी नंबर ऑफ इंस्ट्रक्शंस एग्जीक्यूटेड बढ़ता चला जाएगा. yes or no? yes or no?
Yes ma'am.
now एक प्रोग्राम को लग रहा है 3n plus 5 टाइम. सपोजिटली कोई और प्रोग्राम है उसे लग रहा है t2n टाइम, which is 4n square times. So now from this we compare that which program is taking less time, that will be better program. This is how we compare the time complexities. Okay? So now the question is 3n plus 5 is better or 4n square is better. How do we know? क्वेश्चन समझ में आया मेरा? मैंने क्या बोला?
Yes, ma'am.
Yes, ma'am.
कुछ values
This is how we calculate
better
time
होगा, but
complexity.
कुछ values के लिए 3n plus 5.
क्या बोल रहे हो राधा? To compare 3n plus 5 and 4n square या कोई और फंक्शन, उसके लिए we do something called as asymptotic analysis. Asymptotic notations हैं जिसमें growth of function पता चलती है, हम उसका analysis करते हैं. अब हम देखते हैं कि इन सबका मतलब क्या है. Let us try to understand the asymptotic notations now. ठीक है. So this is how we calculate the time function. ये बताया मैंने. ऐसे ही space complexity का function calculate कर सकते हैं. This is the time function that we have calculated. Now, before understanding the analysis, we are moving on to asymptotic notations. A very important and new concept. Try to understand. कुछ notations हैं. Asymptotes क्या होते हैं? Asymptotes are line which we are drawing till infinity and they never touch the axis till infinity. They are almost parallel to the x and y axis, but they don't touch the axis, right? So supposedly n is lying on the x axis and t of n is lying on the y axis. T of n वो time का function है. Now if I am drawing tn is equal to n, अगर tn is equal to n draw करेंगे, such a line would be there, yes or no? Linear line 1 1 2 2 3 3 and so on. ये ग्राफ समझ आ रहा है सबको?
Yes, ma'am.
Yes, ma'am.
Similarly, if I am plotting for 3n, it would be something like this, 3n. And if I am plotting for 3n plus 5, it would be 3n plus 5. But it is still a linear graph. टेढ़ा मेढ़ा नहीं है. It is still a linear graph, a straight line graph, no curves. Are you all understanding? Yes, no.
Yes, ma'am.
Now, अब ये तो हमें पता है कि ऐसा है. अब दूसरे फंक्शन का एक और ग्राफ है. 4n square graph will be drawn in this manner. This is supposedly graph for 4n square. Again, this is n and this is t of n. Now, which is better? Which is better हमें पता करने के लिए हम क्या करते हैं? We use a way. अगर हम 3n plus 5 को प्लॉट करेंगे तो वो कुछ ऐसा प्लॉट होगा. This is 3n plus 5. So what we are trying to do is जैसे जैसे कोई certain point है n0, इस n0 के बाद 4n square is always greater than 3n plus 5. After certain value, 4n square will always be greater than 3n plus 5 for some n greater than n naughts के लिए. All of you agree?
Yes, ma'am.
So what happens is जब हम asymptotic analysis की बात करते हैं तो we assume that n can reach till infinity. So if we are talking about till infinity, which will take lesser time?
3n plus 5.
3n plus 5 is always the better algorithm as compared to 4n square, correct? Why? Because 4n square की जो line है ना ग्राफ में वो हमेशा 3n plus 5 से ऊपर है. ये clear हो गया सबको? इसको बोलते हैं upper bound. This is something called as upper bound on this line. इस line को after a certain point 3n plus 5 is upper bounded by 4n square. इससे ऊपर कभी भी नहीं जाएगी. This is how we define the very first asymptotic notation, which is called as a big O notation. Big O notation or big O notation, capital O I am writing, and it is also called as the upper bound on any function. Upper bound. अब ये क्या कहता है? If I am having a graph and if I am plotting some graph which might not be a straight line always, this is my f of n जो कि एक given function का time analysis है. I want to find a g of n. मुझे एक c एक और constant है into g of n एक और function है. मैं g of n ऐसा find करना चाहती हूँ so that f of n is always less than fn जो है वो gn के ऊपर अब कभी नहीं जाएगा. Always less than c into gn for positive constant c and n naught such that for all n greater than is equal to n naught, this condition will hold. For all n greater than equal to n naught के बाद fn is always less than c into gn. Is it clear? If this holds true,
Yes, ma'am.
if this holds true, then we say that f of n is upper bounded or big O bounded by gn. तो हम कहते हैं fn is big O of gn. फिर से बता रही हूँ, फिर से समझ लो what I am trying to say. सुषमा, I am repeating it, no issues. कोई बात नहीं. I am saying if I am having a function, supposedly this is some function O of 1. This is some, ये ऐसे समझो, वही 3n square वाला फंक्शन ले रही हूँ मैं. This is 3n plus 5 and this is n square. कुछ वैल्यू के बाद 3n plus 5 is always less than n square किसी particular n naught के बाद. Some c into n square किसी constant से multiply कर देंगे 1 2 3 4 5 something like that. उससे हमेशा छोटा ही होगा 3n plus 5. Right? For some positive constant c and n naught, for all n greater than is equal to n naught, this will always be true. If this is always true, then we say that 3n plus 5 is upper bounded by n square. Big O of n square. Is this much clear to all of you? I am having a function 3n plus 5. ठीक है? Now I am saying this function will always be less than 3n plus 5n. 5n से हमेशा छोटा ही होगा ना for n greater than 1. Yes or no? ये तो clear है सबको?
Yes, yes, ma'am.
That means this is always less than 7 into n. ये clear है सबको? That means graph पे when I am plotting this 3n plus 5, this 3n plus 5 will always be less than 7 into n. Not like this, but 7n का graph after n is equal to 1, it will be like this. So after some n naught is equal to 1, जो कि हमारे केस में है, and for some c is equal to 7 जो हम मिल रहा है, I can say 3n plus 5 is always less than 7 into n. Can I say that? For all n greater than 1? Yes or no?
Yes, ma'am.
That means n plus 5 is upper bounded by 7 into n. Or I can also say that my 3n plus 5, हम क्या लिखते हैं, f of n is equal to 3n plus 5. So I can say that this fn is upper bounded by n. I have found that 3n plus 5 is upper bounded by the function n. इसके आगे का constant कुछ भी positive constant हो, we are not interested in. Now are you all able to understand कि what is the upper bound? Upper bound का मतलब है कि ग्राफ में n नॉट के बाद कभी भी 3n plus 5 वाली लाइन 7n के ऊपर नहीं जाएगी वैल्यू में. इससे ज्यादा टाइम कभी नहीं लगेगा हमें. That means I want to say that this function is of the order n. So around n टाइम लगेगा इस एल्गोरिथम को एग्जीक्यूट होने में. n से ज्यादा टाइम asymptotically the algorithm will never take to execute. Now is it making sense to all of you? This is known as the upper bound or the big O notation. Is it now clear to all of you? What are asymptotes? Asymptotes are lines that never meet till infinity. Yes or no? Lines जो axis से कभी नहीं करेंगे till infinity. Are those called as asymptotes? I don't want these two lines to meet. ऐसा नहीं चाहिए मुझे कि these lines should meet. What I want is that after given n naught, 3n plus 5 का जो time है वो 8 is some constant into n से ज़्यादा कभी नहीं जा सकता. So I can say that this algorithm is of the order n, or I can say it's a linear time algorithm. ये लीनियर टाइम ले रहा है. Yes, I do realize that. This algorithm is going to take linear time. Correct? Is this clear to all of you? The next is a lower bound, also represented as an omega notation. Omega notation, right? So there is a capital omega, small omega, and all that. So again, I would, in the graph, if I want to graphically represent this, if I am having some function f of n, I want to find another function g of n such that beyond a certain point n naught, some constant multiplied by the function g of n will always be less than the given function f of n. That is, I am saying for positive constants c and n naught, f of n is always greater than equal to c into g of n for all n greater than is equal to n naught. If this condition holds, then I would say that f of n is lower bounded by the function g of n or vice versa, one and the same thing. ठीक है? The upper bound is on the upper side, the lower bound is on the lower side. That means minimum g of n time the function will always take. इतना कम से कम time तो लगेगा ही लगेगा. So if you're not looking at accuracy, or you're not looking at, and you want immediate quicker possibility, then you might be looking at a lower bound also, so that you might be able to compare a lower bounds term also. So for whatever reason, minimum itna time to the function will take definitely. A yes or no? Shall I take an example for the same? So now supposedly I'm taking a similar example as I took yesterday, so that we blend in with the similarities of what we had done yesterday. So I am taking f of n to be 3n plus 5 as we calculated for the program we were doing. Now I'm saying I want to find a lower bound. I'm now looking for a lower bound, right? So what is the lower bound on the function? This function should always be greater than some constant multiplied by gn. So what am I going to do here? For this function to be greater than, always greater than the next part which I am writing. If I am writing this function is always greater than 3n, because I am removing the term with 5. Will this function always be greater than the 3n? Yes or no? I am keeping the leading term and I am removing all other positive terms. The method that I am using here is I am keeping the leading term in the function and I am removing all other positive terms. So function is always greater than 3n plus 5 is always greater than 3 of n. Yes or no? Or I can say that f of n is always greater than c into n, where c is equal to 3 and n naught again is coming out to be 1. So for all n greater than 1, greater than equal to 1, I will be having f of n is greater than 3n. That means f of n is lower bounded by n. Are you all able to understand this? Should I repeat? I will re-repeat the question in further details. How did we move on? Was I'm taking another question and I will re-repeat the question. So I'm having f of n is equal to supposedly 7n plus 6. Just taking another example. Now I want to find some g of n. I want to find this g of n such that f of n is always greater than c into gn for positive C and n naught such that this condition will hold true for all n greater than is equal to n naught, right? I have to find this g of n. This is what I have to find in the equation. So I'm saying fn is always greater than 7n plus 6 term I'm dropping. Leading term rakh ke next term I'm dropping. So f of n is always greater than is equal to 7n. When is it greater? When n is greater than equal to 1. n 0 या negative होगा तब तो ये condition true नहीं होगी. So this is true if n is greater than is equal to 1. Yes or no? All of you agree?
Yes, ma'am.
If n is not greater than equal to 1, then this condition will not hold. So when n is greater than equal to 1 only, then the condition will be holding. Now I am saying this 7 becomes C, n becomes g of n, and this 1 becomes n naught. So I can replace it that f of n is greater than is equal to C into n, which is g of n now, for all n greater than is equal to 1, which becomes my n naught, and C is equal to 7 we have found. So can I, if this is holding, this implies that f of n is lower bounded by n. Is it now clear to all of you? As we have the lower and the upper bound, in a similar manner, we have something called as strict bound or theta notation. Now we are coming to a theta notation or a strict bound. Now here I am saying that for a given function f of n, I am trying to find a function, some constant into g of n, which is always less than the given function, also multiplied with another constant, the given function is always greater than the function given function. So I am saying that the function fn is both upper bounded and lower bounded by the same function, implies it is theta bounded by the function. If proper definition let me give, then we'll come to the example. Again I'm saying that for positive constants C1, C2 and n naught, I am saying that if C1, sorry, I have taken this to be C1, so I will take in that manner. C2 of Gn is always less than is equal to f of n. C2 of Gn is always less than f of n, and f of n is always less than C1 into Gn. If this holds true for all n greater than is equal to n naught, then I can say that f of n is theta bounded by g of n. This is known as the strict bound. Is the definition clear to all? Let me know if the definition is clear. If the definition is clear, so I'll take the same example once again. Now we were having f of n is equal to 3n plus 5. I'm taking the same example. Now I want to find the both upper and the lower bound. So I'm trying to find f of n. First I'm taking the upper bound. C1 I'm trying to calculate. So for f of n greater than, I have to find out, sorry, f of n to be always less than the given thing, I'm taking it is as 3n plus 5n. 3n plus 5 will always be less than 3n plus 5n for all n greater than is equal to 1. Yes or no?
Yes, ma'am.
And I can say that this is always greater than 8n. So for C1 is equal to 8, n naught is equal to 1. I have found that f of n will always be less than C1 into n. ये condition मुझे मिल गई है for all n greater than is equal to n naught. That means this is an upper bound. This I have found. Similarly, now I am looking for a lower bound. I am saying f of n is 3n plus 5. This will always be greater than 3n. 3n plus 5 will always be greater than 3n for all n greater than is equal to 1. Again, by chance we are having the same n naught. Otherwise, we can choose the larger n naught. That means for C2 is equal to 3 and naught is equal to 1, once again, I am having f of n is always greater than C2 into g of n. Or I can say that 3n is always less than is equal to 3n plus 5 is always less than is equal to 8n. This is holding C. For all n greater than is equal to 1. This is my C1, C2, C2, C1, and this is my n naught. This all implies that f of n is theta bounded by n. Is it clear to all now? How can we find a strict bound? Is it clear? Anybody, any doubts in the notations? So these are, हाँ बच्चे, please ask. N naught is essentially the intersection point, but हो सकता है N naught एक के लिए यहाँ आ रहा हो, दूसरे function के लिए यहाँ आ रहा हो. So the later value of N naught, जिसके बाद वो conditions always true रहेंगी, that is chosen to be the N naught. Might be the functions are having, जैसे हमारे case में functions will be 3 lines, so technically 0 से they are having that, but we take it to be a positive constant, so we are beginning with 1. It is the intersection, and हमारे केस में इन तीनों फंक्शंस का इंटरसेक्शन पॉइंट 0 है. if you will see, the intersection point is 0. After that the functions will start degrading or whatever. So at n equal to 0 the function value is 5. At n equal to 0 this is 0. This is not greater अभी तक. So the intersection point is 0. उसके बाद आगे it will be growing or not growing, right? So this is about the strict bounds. Now there are loose bounds also. ये तो हमारे एकदम firm bounds हैं. At times when we are having difficult algorithms, it might be possible that we are not able to find out when f of n is strictly, हमारे केस में तो we were having strictly greater than c of gn. At times it is possible this equal to sign we are not able to find out. So we can have that f of n is almost greater than, always greater than c into gn for all n greater than n naught. Equal to का sign हट गया. This is the loose lower bound. So for this we use the small omega notation. Small omega. It is again omega notation, but small omega notation for loose lower bound. Similarly, if I am saying f of n is always less than c into gn for all n greater than n naught, equal to sign अगर हटा दिया है, so this is nothing but loose upper bound. Loose upper bound is also called as small o notation. Small o notation. बाकी सब कुछ सेम है रिप्रेजेंटेशन का तरीका. Similarly, if I am having these without c1 c2 gn की condition में, if I am having that c1 gn is less than fn is less than c2 gn for all n greater than n naught, equal to signs remove, then this is a loose theta bound. Loose theta bound. So this is small theta notation. So small o, small omega and small theta are nothing but loose bounds. Big O, big omega and big theta are nothing but strict bounds. So these are, सिर्फ इन्हीं तीन notations को use करके we perform algorithm analysis. अब ये जो function है ये time को represent कर रहा है या space को represent कर रहा है, it can vary. Based on only these 6 notations, we will be performing comparison or analysis for any algorithm. This is how algorithm analysis takes place. So let us try solving a few questions now. So if I am having a question, supposedly I am having, did I tell you the growth of functions? That big O of 1 will be greater than big O of log n. Sorry, not greater than, less than. The time taken by an algorithm which is taking constant time. This is known as constant time algorithm. Constant time algorithm. This is known as logarithmic algorithm. So what important is big O of 1 is less time than O of log n, is less time than O of n. This is linear algorithm, linear time. Is less than big O of n log n. Big O of n log n is further less than big O of n square. It is less than big O of n cube or anything. This is polynomial time. Still we are in polynomial time. Polynomial time तक के जो algorithms है ना, they are considered to be very good algorithms. Now this is less than big O of 2 raised to the power n. यहाँ से we are beginning with exponential algorithms, and as we clearly saw with the story yesterday, exponential algorithms tend to grow very fast with even very small changes in the size of the input. So we do not want exponential algorithms. We do not prefer. अगर कोई और solution ही नहीं है तो that might be a different case. But however may be the power of n, we always prefer polynomial algorithms over exponential algorithms. This is still less than big O of n factorial or n raised to the power n. So this is how the growth of functions can be assumed or understood. That constant time algorithm is better than logarithmic, better than linear, better than n log n time algorithm, better than quadratic, better than other polynomial algorithms, better than exponential, and better than O raised big O of n raised to the power n algorithms. Is it clear? Is it clear to all?
Yes, ma'am.
So now let's take an example where we are having these terms and we are trying to solve the question. So I'm having f of n is equal to n cube plus n square log n plus 5n. What is the upper bound? Kindly find a strict upper bound for me. Kindly find out a strict upper bound. Now you have to find out the leading term in the expression. Leading term मतलब जिससे कि ग्राफ चेंज होगा, बाकी सब टर्म्स उसमें सेकेंडरी फॉल करेंगी. Which is the leading term here? N raised to the power 3. Because n square log n would be less than n cube asymptotically. I am talking about asymptotically, right? So if I am taking those asymptotes into consideration, this fn will always be less than n cube plus 5n cube for all n greater than equal to 1 here. Again, by every time n naught is not 1, by chance it is coming out to be 1 in our examples, right? So here it comes out to be 7n cube. So my c becomes 7, n naught becomes 1, and I can say that f of n is always less than c into n cube for all n greater than is equal to 1. This implies this is of the order n cube. So I am having an upper bound of n cube on the given function f of n. Is it clear to all?
Ma'am, this is called the strict upper bound or just upper bound?
I am taking big O notation. This is strict upper bound. Although I am clearly mentioning the equal to sign, I am clearly mentioning the equal to sign. So this is a strict upper bound. If I was not mentioning this, then it should have been a smaller o, small o wala o, and it should have been loose bound. But the question is asking big O notation only, and I am also giving the big O notation only. This is a strict upper bound. Fine. Let's take another example now. Supposedly I am having log n plus log of log n. So this is 7 log of log n plus 8. So give me a big O notation analysis for the given function. Again, how will you find a big O analysis? Which is the leading term here? अभी यहाँ से ध्यान रखना, n is greater than log of n. From this we can understand that log of log n would even be smaller only. Because n अपने log से हमेशा बड़ा है, तो इन दोनों टर्म्स में अगर हम इसे एक x ले लें, So we can write this is like log x is less than x. Understanding? So log of log n will be less than log n. Yes or no? ऐसा एग्जाम में कैसा भी डिफरेंट क्वेश्चन आ सकता है, that you will have to understand on your own. So according to this, log of log n will always be less than log n. So I can write clearly here that fn is always less than log n plus 7 log n plus 8 log n. Again, for all n greater than is equal to 1. Again, n naught is coming out to be the same. So if I'm trying to calculate here, this comes out to be 16 log of n. C comes out to be 16, n naught comes out to be 1, and I am getting f of n is always less than my C into Gn. This implies it is of the order Gn or of the order log n. I hope all of you are getting the answers clearly. Let us see another question now. I'll give you more practice questions. Let us try solving more questions here. Now, supposedly I'm having a question. I'm having fn is 2 raised to the power n plus 100 n raised to the power 5 plus 6. Supposedly this is a question. Which is the leading term?
Two raised to the power n.
Correct. This is constant. This is polynomial. This is exponential. So constant is best. Then we have polynomial. Then we have exponential. So this is the leading term. So if it was, you have to find where n raised to the power 5 will be greater than 2 raised to the power n. ऐसा कब होगा? Find me the n naught. 1 से शुरू करोगे तो 1 raised to the power 5 greater than 2 raised to the power 1. False. ऐसा तो नहीं हो रहा. 2 raised to the power 5 greater than 2 raised to the power 2. Again false. 3 raised to the power 5 greater than 2 raised to the power 3. Calculate करो n naught की वैल्यू फटाफट से और बताओ मुझे, so that I can put it here. Understanding now what am I doing? I am trying to write it like plus 100 into 2 raised to the power n लिखना है, plus 6 into 2 raised to the power n, where n is greater than what? I should get the correct value here. So this is also not greater as I can see, if I can understand.
मैम पर
हाँ बेटा.
मैम 2 raised to power 5 तो बड़ा है, लेकिन 2 raised to power 2 से.
हाँ sorry, I am not.
मैम यहाँ पे उल्टा आएगा शायद.
Exactly, ये बड़ा ही है. You are correct. I am not looking for these. मुझे वो चाहिए ना जो छोटा हो. I want to find a term where polynomial time is less than the exponential time. So n raised to the power 5 कब छोटा होगा 2 raised to the power n से? वो वाली term चाहिए मुझे. So since 1 raised to the power 5 is greater, so this is not valid. 2 raised to the power 5 is greater, this is not valid. 3 raised to the power 5 is also greater, not valid. 4 raised to the power 5 greater than 2 raised to the power 4. Now, if you want to calculate, this is 2 raised to the power 2 into 5. So this will also not be valid. This is also not valid. Again, 5 raised to the power 5 greater than 2 raised to the power 5. I believe this is also completely invalid. So for small values of n, this is not happening. But as we keep on increasing the values, यहाँ पे तो power 5 ही है, वहाँ पे it is increasing. Find me a value of n naught quickly. Find me a value of n naught. Similarly, we'll be having 7 raised to the power 5 greater than 2 raised to the power 7. This will all, ये सब not true हैं. मतलब these are all holding, so I am not able to find a value where I want n raised to the power 5 is less than 2 raised to the power n. What should be the value of n naught? Now understand, this is the graph of 6. Constant रहेगा ना, n कुछ भी हो 6 तो 6 ही रहेगा. This is somewhat the graph of n raised to the power 5. And the graph of 2 raised to the power n is like this. This is 2 raised to the power n. I am looking for this value of n naught after which 2 raised to the power n will always be greater than n raised to the power 5. अब समझ में आया? Because it is the leading term in the expression. Had I not to solve it, I could directly have written the answer would be big O of 2 raised to the power n. But I want you all to find out how. Confusion कुछ solve हो रही है?
Yes, ma'am.
So what we are trying to find is positive n naught की वो value जिसके लिए n raised to the power 5 should be less than 2 raised to the power n. ऐसी कौन सी value है n की? If I am taking, now I'll go literally, if I am taking n is equal to 1, then 2 raised to the power 1 becomes 2, and 1 raised to the power 5 becomes 1. So this is 2 raised to the power n की line. This is n raised to the power 5 की line. I want 2 raised to the power n should be greater than n raised to the power 5. यहाँ पे तो greater है, but आगे greater नहीं है. तो I want कि जिसके बाद हमेशा the condition should be true. N must be greater than 20 upon 25. Acha, you get me an answer, correct answer. So I'm saying when n is equal to 2, I'm looking at 2 raised to the power 2, which is equal to 4. And I'm looking at 2 raised to the power 5, which is not equal to 4 or something. This should be equal to 32, I believe. This should be 32, I guess. Right? So again, 4 is not greater than 32. So the condition is not holding. Now I am taking 2 raised to the power 3 is equal to 8. And here I am having 3 raised to the power 5. I do not know the answer, but whatever the answer is, it should be greater only. 3 into 3 is 9. 9 into 3 is 27. Into 3 is... so you have to do it 5 times. I do not know the answer. You calculate and find out.
243.
Hanji beta?
I'm 243.
243. Okay. Find out 2 raised to the power 4. It is important. Find me n. It is very important. We'll continue finding n. So this is 16. 4 raised to the power 5 would be something very high again. 2 raised to the power 5 is 32. 5 raised to the power 5 will be something again very high. Then I'm having 2 raised to the power 6, which is only 64. 6 raised to the power 5, again not good enough. Choti values of n में I am not able to appreciate the difference between polynomial and exponential time. As n increases, the increase would be tremendous. जो अभी हम देखेंगे. This is 7 raised to the power 5. Because this power is fixed. Then we have 2 raised to the power 8. This is equal to 256. Then we'll be having 8 raised to the power 5. Again, we'll be having 2 raised to the power 9, which is 512. 9 raised to the power 5. 2 raised to the power 10 is 1024. 10 raised to the power 5. Now this is easier for us. This will be 1 lakh. ठीक है ना? तो 1024 is certainly not greater than 1 lakh. आप कहोगे मैम, it will never happen कि 2 raised to the power n will be greater than n raised to the power 5. But it will obviously happen. So we have to look for the correct answer. Then we have 11 raised to the power 5. Then we'll be having, and so on and so forth. If we keep on continuing, yesterday we saw 2 raised to the power 20 is 5 lakh something. So we'll certainly not be getting that answer even till then. Then we'll be having 20 raised to the power 5 equal to something, right? So then we'll move on. Somewhere around, say 2 raised to the power 40. Somewhere around 2 raised to the power 40, if you are having, and you are having 40 to the power 5, find me an answer. This is easier. Why have I taken? I will tell you. Can you find me what is 2 raised to the power 40? Because this is 2 raised to the power 2 multiplied by 10 raised to, this can be written as 4 into 10 raised to the power 5, na? So I can say 2 raised to the power 10 multiplied by 10 raised to the power 5. So the answer becomes easier. This is 2 raised to the power 10 into 1 lakh. Answer to be found out becomes easier. So this is lakh times lakh. This will come out to be way greater. So 1024. This is replaced by 1024. And I am having 5 zeros ahead. This is 40 raised to the power 5. Now if I am trying to find out 2 raised to the power 40, this comes to be greater than 40 raised to the power 5. This comes to be greater. This comes out to be, thank you so much Sachi, this comes out to be 10995116277776. So whatever this is, way greater than 40 raised to the power 5. So I have found out, again the value of n is immaterial here. We have found that 2 raised to the power 40 is greater than 40 raised to the power 5. 2 raised to the power 41 will also be greater than 41 की power 5 obviously, and इसके बाद they will be greater. So for n naught is equal to 40 we have found. For all n greater than is equal to 40, we will be having n raised to the power 5 to be less than 2 raised to the power n always. Using this, we
Ma'am,
can take, हाँ बच्चे
30 पे भी आ रहा है.
30 पे भी आ रहा है. It might be possible, I have not checked, but अगर 30 पे आ रहा है तो उसके बाद भी true ही होगा. So even if it has come at 30, the point is whatever the value of n naught is, it is some positive constant. So if I am trying to find a c here, this is 107 multiplied by 2 raised to the power n. So I'm getting c is equal to 107. N naught can be 30 if you are saying I'll agree, or 40. If I'm having this, f of n is always less than 2 raised to the c into 2 raised to the power n for all n greater than equal to 30. Since my condition is true, this implies f of n is upper bounded by g of n, which is 2 raised to the power n. Is it clear to all? See, initially n की छोटी values पे हम exponential और polynomial में difference क्यों नहीं कर पाए, क्योंकि power high थी and यहाँ पे 2 की power थी. But even for the smallest possible exponential term, we can clearly see जब हम asymptotically जाएंगे, so algorithm analysis के time पे 40 is technically very small and not. Input size of 40, अगर हम कोई data manage कर रहे हैं, 40 vehicles का ही data manage कर रहे हैं, some algorithms is just reading the data. So thousands of vehicles pass through a single traffic light. If we are having some algorithm just to monitor how many signals have been broken and how many have not been broken, 40 is very less. So even for that, the algorithm is going to take a lot more time if the algorithm is exponential as compared to a polynomial time algorithm. That is why when we